to Engineers Workshop. So we're working on the second half of the post-Anvil project, which is made out of a sledgehammer head. But before we get to that, man, I see a lot of new people here. I want to welcome everybody that is new subscribers from Keith Rucker's channel. So Keith and I have been corresponding back and forth. Actually, I know Keith and have talked to Keith years ago when his site was known as owwm.com, oldwoodworkingmachines.com. That tells you how far back I've got some correspondence between me and Keith. But most recently, he contacted me when I purchased the Kearney & Trecker 2D rotary head mill. I wanted a vertical mill, and I was looking at Bridgeport's, and I kind of happened on this. I think I stumbled on this from watching Ed Callahan's channel. That is one that you guys got to take a look at. Ed's got a lot of interesting machines. He doesn't have a lot of videos, but he did have one of these with all the bells and whistles, all of the attachments, and I said, that is the vertical mill that I need to get. And I got it primarily for this feature here, which is the rotary head. This has a built-in rotary table in the head, which is so cool, and that spindle offsets up to 4 inches, which allows you to walk a circle with your cutter. Now, I mean, the possibilities with this thing are pretty endless. It is a roundover king. You can put roundovers on the corners of parts without recentering the part to the center of a rotary table, which is so cool. But really, in reality, the precision of this thing allows you to mill an interior or an exterior circular feature, and then using the vernier here, and I mean, I've done this with a good rigid setup, sharp cutter, and if you're willing to split the thousandths line graduations on here, you can literally open up an ID or an OD by 1/1000th of an inch. I've done it. Can under all circumstances, but you know, like I said, if everything is just right and you have a good rigid setup, good sharp cutter, you can split thousands with this thing. Now, Keith asked me a few questions about it, but I ended up sending him one of these, and I think you guys saw him open it up on air live. And did you catch the surprise in his demeanor when he saw how nicely it fit? I mean, I just designed it based on the dimensions of the part, and then what he was referring to was, if you zoom in here, I used this setup, and I have 2 locating holes which are exactly 5 inches apart. I had 2 of these fixtured, so I plotted out all of the coordinates of the different radii here, and I rounded over the edges of this part, which I got from Send Cut Send, on the K&T mill. So I'll link to my video where I did that, and I think Keith was referring to the fact that he may be doing that, you know, in the future to make his a little bit more friendly on the hands. It is definitely nicer to hold on to with those edges rounded over. I was happy when Keith got one of these. Then I thought, oh crap, Keith is going to buy all of the available goodies off of eBay and from private individuals, all of the universal milling attachments and the right angle attachments and all the collet sets. Keith's going to buy it all up, which he's in the process of doing. But he did manage to source me a correct spindle switch, which you can see has a protection feature for center off. You have to go, you know, to off before you can reverse the direction of the spindle, but we'll do more with this in another video. Right now I've got to finish up this post-Anvil, and that's lathe work at this point. So hope you enjoy. For your new subscribers, the content here. I'm just a hobby machinist, been an engineer for 30, 35 years. And I've always dealt with machine parts, but on the side of feeding drawings to machine shops to make stuff, fabrications and tooling. So getting into it myself now, trying to get it to a point where I can make anything that I want, both machining and fabrication wise. So that's my story in a nutshell. Let's get back to the project of this post anvil. Thank you. I decided to run this without tail support because it seems stable enough, and I'm just basically taking about 10 thousandths deep at a time until I get basically a full flat diameter. It's going to take quite a few passes, but then we'll start working those angles across. Might be getting into a softer area of the steel. Definitely just started to chatter there. I've set my compound to 30 degrees. I'm gonna back cut this so that I have a consistent starting point. When this tool enters the surface here, it's a lot of thumping and chatter, so when I'm cutting these 1, 2, and 3 degree angles across here, I want to have a consistent lead into that. So I'm going to do an initial cut, a back cut until this all cleans up, and then take one last light cut across the face, then we'll blue it up. For the working end of the post anvil, my son wanted to have a very slight radius surface instead of something perfectly flat. So I set up in SolidWorks and made a rectangle of the same width as the head, which is about 2.88, 2 7/8 inches. And I just started playing with a couple of different radii to see how much drop there was by the end of that, by the edge of the hammerhead. And what seemed to be about right was a 24-inch radius. And the way to approximate that, because I can't swing a radius on the end of that, was I'm going to approximate that radius with a couple of flats, just run with the compound. And I'll still keep the center supported. I'll probably put a very small lathe center in, and then cut the front face and leave a tiny post sticking up with that center. And then I will blue the face and set the compound at a 1 degree, 2 degree, and 3 degree angle, and pare that face back until I get the approximate diameters shown here. The flat is going to be about 0.8 inches, about the size of a quarter, and then a 1 degree angle cut. I'm going to bring that back to a 1.6 diameter, and then a 2 degree angle cut will be 1.26 diameter, and then the final 3 degree angle cut will clean up that very outermost edge. Each of these will only deviate from a true 24-inch radius by about 4 thousandths at their end. So he can take his angle grinder at the end, or maybe I'll just still do this on the lathe, after I grind that post off. Spin this at a real slow speed and just work across that surfaces to take those high points off, and that will be pretty doggone close to a 24-inch radius. So let's set this up in the lathe and get started. I'm not sure how clear my SolidWorks screenshots were, but here's what I was attempting to do. So we've got a face that I machined on the lathe, and I machined that just, with the carriage. So I did a perpendicular face. Let's put a center line on here. Then what we're trying to do is we're trying to approximate a 24-inch radius on this face, which, you can't really do easily without something CNC. But if you look at and break this into segments, you've got some diameter here that's essentially flat. And then at that point, what I said I could do is I can machine a 1 degree angle, and that'd get me to about here. And then I'll machine a 2 degree angle. And then I'll machine a 3 degree angle. Now these I can do on the compound. And then when you're done, you end up with essentially an approximation of that 24-inch radius with a few high points that you can easily dress down with an angle grinder, flap disc. So all I did was lay all this out in SolidWorks, got the relative diameters of the flat, of the 1 degree, of the 2 degree, and then the 3 degree basically takes it off the edge of the part. And that's what I'm going to set up for. You can't set my compound. The scale is not oriented to where you've got the travel of the compound in this direction, and then you've got an indication where the 1 degree and the 2 degree and the 3 degree are. So I'm going to use a method of just stepping this off of a 1-inch travel, and using the tangent function to compute the drop in 1 inch for 1 degree, 2 degree, and 3 degree. And in order to do that, you have to angle the compound, put an indicator on the side of the compound, and then traverse the actual saddle, the cross slide on the saddle, to let that indicator ride down that 1-inch slope on the compound and play back and forth, bump it around until you get the correct drop for all those different angles. So easier to see it done than to explain it, so let's go over to the lathe. The scale of my compound does not have a pointer position that allows me to hit, like a 0 degree in this orientation or a 1 degree. So I have to go back to geometry and basically take the tangent of 1 degree. Let me go back here and verify my math. And that's 17.5 thousandths travel over 1 inch. So and I've got my pointer on 0, I don't know if that's something that you can see. Let me see if I can zoom in here a bit. Change the angle of my lighting a bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's 15 thousandths. That was my first guess. So we'll tweak this just a hair. Re-0. Try again. Yeah, it's pretty doggone close. So that's 1 degree. That's the first facing cut. And we're going to try to take the diameter on the center of the axe head to about 0.84 inches. Put the indicator set up aside because we're going to need that for the other 2 cuts. Now the next issue I have is, being that the compound is traveling in this direction, I mean, that was my fine adjustment for in and out on all those facing cuts. And now I just have the, coarse movement of the hand wheel on the saddle. So I'm going to have to use the carriage stop here. Just keep it tight against the carriage stop and then dial the carriage stop back a few thousandths at a time to increase my depth of cut. I'll do my best to show you what's happening here. Okay, I'm tight against the carriage stop. So advancing the compound by hand. You can see I am removing blue. And it looks like I'm done. A couple thousandths of carriage advance at a 1 degree angle is going to give me a lot of depth of cut. In other words, it's going to result in a big change in the diameter of my finished center pass. I'm literally moving that carriage stop like 1,000ths at a time, and this thing is just shooting across the face here. I think I can do maybe one more adjustment. Still up over an inch. Let's go a tiny bit more. Yeah, somewhere between 800 and 900 thousandths, so that's our target for the first. Tangent of 2 degrees is 35 thousandths. 32 thousandths on my first guess. Well, we're a tiny bit high, but we'll take it. Lock that down. So this time we take our cut up to about 1.6. insert is acting like it is not sharp. I'm going to flip it. Definitely was just a crappy insert. I'm there. I'm rated 1.5 inches. This last adjustment, 3 degrees, is a 52 thousandths drop. 1, 2, 3, 4, 5, 6, 7, 8. Ran out of travel. It's about as close as I'm going to get it, so we'll run with that. So basically on this one, we're just barely taking away the outer edge. And there it is. A 24-inch radius approximated by a flat, a 1 degree, a 2 degree, and a 3 degree cut. And the rest he can touch up with the angle grinder. Trying to get this exactly right. Yeah, you can see it. There's the flat. Well, there you have it. If you want to look like a pro, get yourself a sledgehammer head from an antique store for 10 bucks and have at it with the lathe. Somewhere I read that hammers are possibly A2. I'm going to take this over and do a test real quick with a Brinell tester and see what the hardness is, but I think it will suit his purposes. So thought I'd show you the King portable hardness tester that Doozer gave me. It's really cool, very light and very easy to use. It's a Brinell tester, which gives you basically a complete overlap of the Rockwell C scale, and I think the B scale as well. You can test pieces up to about, I don't know, 8-10 inches thick or down to nothing. Just ran a test here on the washer. That's dead soft. But you use this in conjunction with a Brinell scope that has, unfortunately you can't look through here and see it, but it has a calibrated scale etched onto the glass, and you read the diameter of the indentation to determine the hardness. Now, I did one here at the side, and I'll tell you what that turned out to be here in a minute, but I wanted to test one on the unmachined face close to the head. This was already pressed on by my son. He didn't end up welding it because it was a tight press. So I'm going to try to get this situated here kind of close to the edge, centered on that facet here of the head. Basically, you shut off the hydraulics. And then you pump it up until it's reading 3,000 kg. And you give it just a few more pumps. And then you release. And there you have an indent. Now let me read the diameter of this with the scope, and I'll bring you back and tell you what this thing checked out. So here's our handy little chart. Any guesses what the hardness of a sledgehammer head is? At the head, unmachined area, we had a indentation 3.3 millimeters as measured with the scope, which corresponds to a Brinell hardness of 340 with the 3,000 kilogram load, 36.6 Rockwell C. Earlier, I had tested just the middle on the side where I had machined to flatten this, and I got a 3.9 millimeter indent, 241 Brinell, 22.8 Rockwell C. So these are about like a grade 8 cap screw, depending on the diameter. I believe grade 8 cap screws, they're either 37 to 42 or something like that. But you know, reasonably hard, not super hard, but obviously why this machined so nicely. And even just in the sides here, you know, the hardness was, you know, kind of like a 4140 pre-heat treat, 27 to 32, maybe a little bit low here because I've already cut underneath the skin. So these are probably case hardened or flame hardened at the striking faces to be a little bit harder than the center. So I thought you'd find that interesting. And here is the completed post anvil. He has to mount it to something solid, but it's a 2-inch pipe, a floor flange, and then the interchangeable couplings. I believe he has a short version as well. So he's already tried it out. I don't think he's even bothered to blend the flats because my bluing is still visible there. And it's not an indent, that's just a discoloration. Boy, it looks like just looks like a dish there, but that's completely flat. Just a change in hardness of the material there in the center. I hope you enjoyed that 2-part series on doing a post anvil from a sledgehammer. Boy, that's something I never thought I'd be machining, but it turned out to be quite entertaining. So once again, welcome to everybody who is a new subscriber from Keith Rucker's channel. I try to do a lot of different projects. I've always got something going on. My son keeps me busy. Love playing with the K&T. Been doing a lot on the lathe lately. Reorganizing this big shop. This building, I didn't mention it earlier, was a sawmill, and we bought this property a number of years ago, but decided to move, you know, my fabrication and metalworking shop over here. The building is 50 by 125 and has 16, 17 foot tall sidewalls, so a lot of space to grow. Unfortunately, it's not completely enclosed, so I do have to work on that as time and money present themselves. I put in a 3-ton overhead hoist and trolley so I can move offload machines and move them from one side to the other. I got a couple other hoists here and there that I use. I have a 1-ton over at the lean-to, and I have a 1/2-ton that I kind of move around as necessary, but trying to get this place organized and get like all the metalworking side over here. That side's probably going to be woodworking, stock storage at that end, maybe QC department at that corner someday. I'll get into all that equipment later, but hey, you know, one project at a time for now. Now that the weather's nicer, I'm able to work out here a little bit more and without breaking too much of a sweat. So thanks again for watching and subscribing. Don't know what I'll be doing next week, but I will do the next project on the list, and we'll catch you next time on Engineer's Workshop. Until then, as always, stay safe.